Hi, welcome back to this channel. This is the second part of Modulation Distortion Setup guide. In the part 1 of the video, I show you how to get to where we are right now on the screen. I'm going to show you how are we going to call the VSA software and do a quick measurements and compare it to the EVM of the output that we are seeing right now. So if you have a PNA, you have to install the VSA software into it prior to this step. So we go to Mode Setup, go to Measure, VSA Setup. Then if you have a VSA installed prior to this and reboot, and then you can do this. Just click Connect to VSA. So this is because of the licensing from. So let's set the band. So sweep band instead of 200 meg, let's set it to 120 meg. Okay, I can go to 120 meg because of my setup. We have 50 meg on the starting, the low part of the ACP, and then we have middle 50 meg, and then we have the upper 50 meg. So all in all is about 150 meg. So let's go to measure again, VSA setup, then we click connect VSA. So you take roughly a minute or two if it's the first time you're running with the VSA software. Just need to initialize, boot up that software. Let's just wait for a while. So once you see a tick there, it means that the VSA software is reading, but it's hidden at the back. So you can click Show VSA. So this is how it looks like. So it's a bit of confusion here. So channel 1, it becomes the output of the amplifier, and channel 2 is the input amplifier. If that confuses you, you can always change the orientation of it. How to do it is go to Input, Channel, Custom. So as you can see here, the B is from channel 2. It has gone to channel 1 of the measurement here. You can either switch here or you can switch here. It's up to you. How to do it is just drag, and let's drag it to somewhere else, and so that it will be terminated. Then we drag. So B is on channel 2 of the PNA, it goes to channel 2 of the VSA. And A is channel 1, it goes to channel 1. Let's click apply, and there we go. Channel 1 is input, channel 2 is output. Okay, fine. Let's go to change that. So from normal vector, which is just a spectrum and time domain measurements, go to general purpose, digital demode. It looks like a mess because it is. We haven't finished setting up. Let's go to digital demode property, and because we did a QPSK signal, let's go to QPSK, and our bandwidth is roughly 40 meg. You can increase the number of points per symbol. It's just to average out the reading, make it more stable. It doesn't really matter. Let's go to filter. So if you remember, I did mention in the first part of the video, we have to remember the alpha. We did use 0.25 instead of 0.35. Okay, so we sort of done. So you can see the input EVM is roughly 2%, output is 2.4%. Well, you might say that it's a bit different. Let's go to here. Let's do that. So it's until 1.9, sorry, 1.59. So how do we increase that? Because in the PNA, we do have the equalization turned on. We have to turn on this VSA software also, just to do apple-to-apple comparison. And this is where we go to compensate, equalization filter. So it takes some time to stabilize. And as you can see, stabilize about 0.8% of the signal, which is quite good. How do you know whether the equalization is working? Let's drag this over here. Oops, I do not want this to happen. Let's drag this over here within it. Yep. And let's change this to, instead of equalizations, we can see the impulse response. So this is how the equalization has taken place. This is on channel 1, which is the input. Let's do it the same for the output. To see the equalizations works, you can either use the impulse response or you can see the frequency response. So both are part of the equalizations method. So let's change this to equalizations, impulse. Yep, it's almost similar. Okay. So of course there are some other setup that we need to take care of just to match the same EVM value between these two. But of course, two different methods might yield a bit of deviations. If you want to know in detail, do contact the Keysight personnel. They should be able to share with you some of the knowledge behind these equalizations and also this measurement. What is equalizations? You can read through in Wikipedia, and this is the help file in the VSA software, which explain quite a lot on how do we apply the equalizations, what does it do. And one more thing I want to show you is this. So in the event where you know that you're driving the amplifier to high, to a saturation point, let's say we set it to -12. So we can see that the ACP is quite far, quite close to the carrier. This could be two things. It could be saturating the ADC, the internal ADC from on the PNA, or this could be really from the amplifier, the device under test. So how do we test that? Let's go to power and attenuators. So as you can see here, we can set the internal attenuators as we wish, different paths. So currently we are doing the receiver on B. So currently it's at 0. Let's set it to 20 to see is there any changes over here. It doesn't change much, it means that it's not saturating the ADC. This is one of the tips that you can try if you suspect that you're driving too much on the internal ADC. And the other things that you can try is, let's set it to 5 first, just protect this. So the other thing that you can try is, let's go back to mode setup, setup, and we can right click it and show the expert tab. So the expert tab will show you all the setup that's available for the backend source and all this. And then we can go one level up, so we call it advanced tab, even higher. Let's go to the ADC and LO. This way you're going to see the ADC range. So currently at the B receiver, which is a receiver for 2, the ADC is about 29%. So if let's say I change that to the attenuator to lower, to 0, you can see that it's pushing from 29% to another level. So it's 51%. You can see that it's reaching to the point that it's trying to saturate the ADC. So once you go into here, if you see the value is too high, we do recommend to go to power, attenuator, just to protect your investment. Let's increase something to 20 dB maybe, so that your ADC is not saturated. That is a good number. Okay, well, that's it for this video. So we cover how to set up for the VSA software, what are the things that you should know, and then how to set up for the VSA, compensations, equalizations. You can actually look for it, more information on it for this video. Thanks for watching.